Press record. Notes about absolute value inequality word problems. So today we're going to start with talking about how does tolerance relate to an inequality. Remember, tolerance by definition is what is your give and take in a situation. The same thing for mathematics. When we're looking for our tolerance, we're going to call that our T. Okay, it is our maximum value that we will allow minus our minimum value that we'll allow, divided by 2. That is the tolerance that we will allow, okay? That's our give and take. What is the median value? Median value or the intended value, that's called our I, our intended value, okay? And that's our middle of our inequality, the middle of the inequality. Okay, it's the middle of our inequality. So our I equals our max minus our T, or our I equals our min plus our T. Okay, that's our intended value. Now when we put it all together, oh, I'm in the same page. When we put that all together, we're going to call that our goal. So our goal is to be absolute value of x minus I is less than or equal to T. Okay, so when we're setting up the word problem, our I, our T, and our x minus comes together in this inequality. So here it tells us a length of 36 8/10 millimeters with a tolerance of 5/100 millimeters, okay? So the first thing we want to do is set up the absolute value. And we want to set up the absolute value by identifying what's our I, what's our T. So one is set up our absolute value inequality. So we're going to identify what's our I and what's our T, okay? Your length that's given, that's your intended value. It's telling you this is your length. And it has a tolerance of 5/500 of a millimeter. So my I equals 36, and my T equals 5/100. So I can set up the inequality, and it's going to be absolute value of x minus 36.8 is less than or equal to 5/100. Okay, so that's step one. Step two is to solve the inequality. And because it's less than or equal to, we know we're solving with compound. With a compound. So if you remember from last week, when we're solving less than or equal to inequalities, we're going to create a compound situation. So the compound here would be negative 5/100 less than or equal to x minus 36 8/10, which is less than or equal to positive 5/100. Okay. When we are going from absolute to compound, that removes the absolute value bars. So an absolute value equation can be represented as a compound. Let's go back over that piece from last week. And now we're just going to solve. So to solve, I'm going to add 36 8/100 to both sides. And when I add 36 8/100 to both sides, I'm going to be left with 36 and 75/100 less than or equal to x less than or equal to 36 85/100. Okay, so what this tells me, after I've solved, I'm now going to put in words of the problem. So in the end, my maximum value that the length can be stretched to is 36 and 85 millimeters. My minimum value that it can be stretched to or compressed to is 36 and 75 millimeters. And that is just finding your tolerance. Not your tolerance, finding your maximum and minimum, given your intended value and your tolerance. This is starting off as a simple word problem. Now, here's another one. So on this example, again, they're giving us our intended length and they're giving us our tolerance. Our intended length is 9 and 55/100ths. So this is my I. This is my T, my tolerance, that it can be stretched and compressed in between. So 1, writing my absolute inequality. So when I write my absolute inequality, it starts off as x minus 9 and 55/100ths is less than or equal to 200. Step 2 is to solve. And again, I'm solving using compounds because it's less than or equal to. So I'm going to use compound inequalities. And I'm going to have a negative 200ths less than or equal to x minus 9 and 55/100ths less than or equal to positive 200ths. I'm going to isolate the x, which means I'm adding 9 and 55/100ths. And that's going to leave me with 9 and 53/100ths is less than or equal to x, which is less than or equal to 9 and 57/100ths. So by the end, I could state that my max value would be 9 and 57/100ths millimeters. My min value would be 9 and 53 millimeters. And that would be finding your max and min, giving your intended value and your tolerance. So I'm going to pause, give you a chance to practice it, and ask your questions if you have any. All right, so for this problem, again, your I, your intended value is 100. Your tolerance is 4 inches. And so notice here, though, this time, it was a trick. Did y'all notice the trick? Did y'all notice the problem? Did I catch you? Notice here this time that your units are not the same. So you have 100 yards and 4 inches. So in order to have set this up, they need to be in the same units. I and T, that's an E, need to be the same units. Okay, so before you can set it up, you have to decide, are you going to turn inches into yards or yards into inches? And so for me, I'm going to go yards to inches because I don't want to work with a decimal. So for this problem, the first thing we have to do is convert. Okay, and remembering that 36 inches equals 1 yard. So therefore, if I have 100 yards, then that's going to equal 3,600 inches. Okay, so this one had to be converted. So now, this is my new I. My I is 3,600 inches. And then now on step 2, I can set up my inequality. So my absolute value would be the absolute value of x minus 3,600 is less than or equal to 4. And now I'm going to solve it using the compound. So setting up my compound would be -4 less than or equal to x minus 3,600 less than or equal to 4. I'm going to add 3,600. And that's going to give me 3,596 less than or equal to 3,604. And so here would be my max, and here would be my min. And currently it's in inches. If the problem didn't want it in inches, then I would have to convert. And to simply convert, I would divide by 36, right? So if I wanted to convert back to yards, so I got the inches, but if I wanted to know how many yards, so my max in yards would equal 3,604. Oh, did y'all see that 3 disappear? Divided by 36. So I plug that into the calculator, 3,604. And the reason why I'm dividing by 36, my friends, is because there's 36 inches per yard. So if I have 3,604 divided by 36, that's going to give me approximately, an approximation sign, 101/10 yard.
Miss Jones.
Yes.
You put the 3,604 as a minimum. Is that
Oh,
right?
I wrote them backwards. I wrote it right on the other side. Thank you. Thank you, Sarah. I wrote it right here. I don't know what I did, but good call, Sarah. So my max yard, 3,604. So my yards, and then my min yards would be me taking that value, 3,596, dividing it by 36, getting an approximate value. And I get approximately 99 9/10 of a yard. So the purpose of this problem was to show you to be careful when you are looking at your intendant and your tolerance, making note that the units must be the same, and then working the problem like normal. Pay attention if it wants the final answer in inches or if it wants it in yards. Notice how I have my inches, but if the answer wanted in yards, I convert it. And the way I convert it is, if we remember, to go from a small unit to a large unit, that's division. When we went from a large unit to a small unit, that's multiplication. All right, any questions about finding the max and min given your tolerance and intendant? No questions? Okay, that's good. Yay. All right. This problem, we're going to go backwards. So now you're given your max and min, and you're going to find your tolerance and your intendant. Okay, so we're going backwards now. So the first thing we're going to do is find the tolerance. So let's read the problem. A friend is planning a trip to Alaska. He purchased a coat that is recommended for outdoor temperatures from -15 degrees Fahrenheit to 45 degrees Fahrenheit. Let T represent the temperature for which the coat is intended. Okay, so we're going to work our way. We have our max and our min, and we're going to find our intendant and our tolerance. So first thing first, we talked about the tolerance is your max minus your min divided by 2. So for this problem, my max equals 45 degrees Fahrenheit, and my min equals -15 degrees Fahrenheit. Okay, so to find my tolerance, it's going to equal 45 minus -15 divided by 2, which a negative times a negative is a positive. So that gives me 60 divided by 2, which equals 30. So my tolerance is 30. So now I know T equals 30. Okay, so to find the median, your desirable value, your intendant value, all you're having to do is thinking about adding and subtracting. So let's look at that on a number line. So if I have a number line and I'm looking for my intended value, my I, it is the distance between my max and my minimum values. So over here, I have -15. Over here, I have 45. And for each one, oops, sorry, I didn't mean to minimize that. I was trying to change colors. I'm asking myself, what is my min plus my tolerance? So this plus 30, or what's my max minus 30? And they should come to the same conclusion of being 15. So it's either way you want to go by it, but they should come to the same conclusion. So my I would equal 15. So I have my T, I have my I, and if I, just to continue to show that it all comes together, I can write the compound inequality. So my compound inequality would be my -30 less than or equal to my x minus my intended, which is 15, less than or equal to 30. So it's the same thing as before. And you can double, this is just kind of checking yourself and making sure you have everything in place. So here's my compound inequality. If I go back, work backwards and solve this, I'm going to end up with -15 and +45. So that lets me know that I have my right numbers. So therefore, I'm writing my absolute value inequality. I can create my equation, my inequality. So my intended, my I equals 15. My tolerance is 30. And so this is the weather that it's made for. This weather is made for whatever X value will satisfy this situation. Okay, and that's it. So this would be your answer. Let T represent, I'm sorry, I should have used T's instead of X's. I just didn't use a little t because of capital T being tolerance. It just was in my way. So I substituted T equals X. Represents the temperature for the co-intendant, and that's it. Now you have your temperatures that you can find. So any value of X that satisfies this is the intended temperature. And that's it. All that. Now we're done. So your assignment is located in Canvas. Follow all the instructions. You have 2 days to complete and upload results and work. So this assignment is accumulation of Friday's work and today's work. You have plenty of time to get it done. You could actually probably get it done today quickly. Just do like before. You're going to make sure you take a picture of your work, take a picture of your grade, and turn it in.
All right, adios. Getting to work.
All right. Any questions, comments, or concerns?